ACABIM, a smart compliance management system for your projects and build assets, powered by a human-guided, workflow-driven automation engine. Fully support open standards. ACABIM offers 6 different solutions for different phases of a project lifecycle, from land development, planning, design, construction, operation, and retrofit. Let's take a look at how the compliance checking process works during the design stage. First, select a project with IFC model to work with. Once the project is selected, you can look at various details of the building including its embodied carbon. You can view the building models and look at various properties. This is a single-story residential building in the city of Christchurch, New Zealand. Let's take a look at a few compliance checking scenarios. Let's check the building for compliance by selecting a CAP. A CAP is BPMN compliant workflows that can query BIM data and legal documents in Legal Rule ML. This particular CAP can be used to check if the vertical clearance of extractor hood above a cooker in a kitchen complies with regulatory requirements. The result is an OK in this case. Let's change some building parameters and see the impact on compliance. Changing the space function has the impact on the type of activity in that space, as well as the number of people that is likely to be in the space. Let's re-execute the CAP to see the impact. As we change the function of the only kitchen in the building to be an office, this results in no kitchen found in the building. Let's look at a few more scenarios. We can change some of the user-defined properties such as cooker fuel type and extractor type. Let's re-execute the CAP to see the impact. We just changed the cooker type from gas to electric. The outcome of the check is no gas cooker found. Further check may be required for electric cooker. Let's change the cooker fuel type back to gas. And let's change the extractor type to just a fan. Let's re-execute the CAP to see the impact. This results in non-compliance. Let's change the cooker fuel type back to gas and the extractor type back to range hood, but also change the installation height of the extractor. Let's re-execute the CAP to see the impact. This results in non-compliance, as the vertical clearance is now less than the required threshold. Multiple CAPs can be executed together in a batch. Depending on the complexity of the checks, it may take a while for the process to be completed. Let's look at another example. This is a 6-story public library building in the city of Christchurch, New Zealand. In this exercise, we are going to check the building for compliance with accessibility provisions. There are several things to check including minimum width of accessible routes, minimum capacity of stairs, and means of escape from occupied spaces. A few violations found. One of the corridors has less than the minimum required width. One of the stairs has steps with the riser height exceeding the required threshold. Note that these violations are marginal and would be considered OK. Another violation is one of the spaces has less than the required number of doors. In this case, 2 doors are required to comply with the means of escape provisions, but only one is provided in the design. Let's look at another example. This is a reasonable large 2-story commercial building in the Auckland city of New Zealand. In this example, we want to know if a lift is required in the given building. The regulatory provisions have several parameters to determine if a lift is required. This includes the use of the building, the number of story, and the number of occupants. In this case, the outcome of the check is that a lift is required given that the number of occupants on the upper level of the building exceeds the threshold for the type of occupancy. Let's look at another building model for the same type of check. This is a single-story residential building in the city of Christchurch, New Zealand. The outcome is that a lift is not required as the building is a single story. Now, let's look at how we can support compliance checking of performance-based requirements. Let's say we want to check the compliance with the means of escape from fire, which is to ensure all occupants can get out of the building in the event of a fire. This could be achieved by generating an input data for the industry standard fire simulation application (FDS), We also execute the appropriate CAP to generate the required input data. This CAP extracts the building geometry and spatial relationships for the purposes of FDS simulations. The generated simulation input data can then be exported to the FDS simulation tool. Subsequently, the outcome of the simulation can be fed back into the CAP. This results in a compliance solution for the project. A PDF report on the compliance checking outcome can be generated if desired. ACABIM is developed by CAS Limited, based in New Zealand.